Hello everyone, welcome back to another very interesting question, good important model question. This is also from Pathfinder, collision relation question here. And this idea has been asked many times in JEE Advanced recently only. So let me read the question. A ball is placed on a stationary horizontal plate. So this is a horizontal plate. At an instant when the ball is projected upwards with a velocity u. So at one instant particle is projected. At the same instant, the plate is made to move upwards with a constant speed Vp less than u, so smaller velocity, in such a way that immediately after every collision, immediately after I have rounded after, you see, meaning not during the collision, after the collision, after every collision with the ball, the direction of motion of the plate is reversed. So first collision it was going up, after the first collision it is going to go down. After the second collision again up, third collision down. So it's keep on changing the direction of motion after every collision, but the speed is remaining constant. That's the meaning he has given. If collisions between the ball and the plate are elastic collision, find average velocity of the plate over a large interval of time. Average velocity they are talking about, okay, after a long time. So to solve this question I will take few ideas, and after that let me go to the question. First idea is, let's say this is a plate you have having a velocity Vp and the particle is having a velocity u and there is gravity down. So if you look at the relative velocity, initially it will be u minus Vp. Acceleration is g only, relative acceleration, because plate will have uniform velocity until it collides. So during that interval plate is inertial frame. So then acceleration due to gravity is the acceleration with respect to Planck there downward, with an initial velocity u minus Vp with respect to Planck. So it goes up and then it is going to come back to the plate with respect to plate, and the time of flight will be 2 times of relative velocity upon relative acceleration, u minus Vp by g. This is the time of flight. So this is the point I wanted to mention. This is with respect to ground and this is with respect to Planck. It goes up with u minus Vp and comes back with u minus Vp in opposite direction with respect to Planck. But with respect to Planck, if it is u minus Vp, meaning with respect to ground you are going to add Vp velocity. So it becomes u minus Vp and added in opposite direction, meaning it is going to be u minus 2 Vp. This will be the velocity of the particle just before colliding with the Planck. It goes up with u velocity, it comes back with u minus 2 Vp just before colliding with the Planck there. So this is one idea I am going to use. These are all simple ideas. You are supposed to be thorough with simple ideas so that bigger questions you can solve easily. Okay, the second idea would be related to collision, elastic collision with the heavy ball, where the ball is not changing velocity. You see here they had mentioned after the collision only the Planck is changing velocity. That means during collision velocity of the Planck is assumed to be constant. Whenever a particle collides with a heavy ball, right, and the collision is elastic, let's say before collision ui is the velocity, after collision the velocity would be in opposite direction, ui plus twice the velocity of the Planck. That is going to be the case. You can write it E equal to 1 speed of approach equal to speed of separation, you will get that, but remember this result. And likewise, if the Planck was going in opposite direction, you will get minus over here, either ui plus 2 Vp or ui minus 2 Vp. When it is approaching you will have severe collision, when it is going away the severity of the collision will reduce. So these are the ideas I am going to use here. Now what I will do is, I feel that, I do not know if that is case, but I feel that to start with that there is a cyclic order here, something is going to repeat after every few events. So it won't be like completely erratic motion. So let's see whether it is going to be the same or not. So whatever question they had given, I am going to study for one cycle and try to see whether there is any repetition going to happen there. Let's say this is a starting point t equal to 0, where the Planck is having a velocity Vp and the particle is projected with the velocity u. So relative velocity initial would be u minus Vp. So by the time the Planck reaches to here, the particle goes up and comes back down, and the time of flight equal to 2 into u relative by g. And by the time it comes down, it will have u minus 2 Vp, same idea. I am going to use this result, u minus 2 Vp, it is going to come down. Now the Planck is going up with velocity Vp. So after the collision, u minus 2 Vp plus 2 Vp will be added. I am using this result. Whatever is the initial velocity before collision you have this. the same velocity will be reversed and 2 Vp will be added here. So u minus 2 Vp plus 2 Vp will become u, that will be the velocity after collision. That means after the first collision again the velocity of the block would be, velocity of the ball would be u only, u started off with, and after the first collision again u. So there is a repetition happening, but the Planck is not at the Planck is going to change its direction of motion, because after collision they said no, suddenly it's going to change its velocity. During collision Vp is upwards, but after the first collision it is going to go down suddenly. Then you see it is going up and this is going down. If you calculate relative velocity now for the next collision, u minus of minus Vp, it will be u plus Vp. So relative velocity is u plus Vp, meaning the time for the second collision is going to be first collision to second collision, the duration I am talking about, that will be 2 times of u relative by g, and then the particle goes up and then comes down and collides with it. See, I am showing it sideways, doesn't mean that particle is going side, just for the visibility, better visibility I have drawn it sideways there. Okay, anyway, so now the particle is going to come down with velocity u plus 2 Vp. Alright, earlier it was u minus 2 Vp because it is going up, now it is coming down, u plus 2 Vp you will have it, just the reversal you will have it. Again if you look at the collision here, what happens, u plus 2 Vp is there, just immediately after collision u plus 2 Vp plus twice the velocity of Vp is added in a downward direction, so the resultant would be again u. So you see again it is coming back to u, meaning after every collision speed of the Planck is coming out to be u. That's one interesting idea, you please go back to it and analyze it, it's a simple one only, and definitely it's a very good idea here. So during collision Planck velocity is assumed to be constant, only after collision Planck is being moved like. Now you look at this situation is similar to the starting again. Again you see after the collision here the particle Planck will move up with velocity Vp and particle has initial velocity u, it is same as this now. So the whole thing will be one cycle here, one cycle corresponds to 2 collisions. One collision while the Planck was going up, the other collision while the Planck was going down. Next moment again the Planck starts going up. So it is going to repeat like this, is the whole cycle you have it. That means the cycle period would be delta t1 plus delta t2. The collision time duration for the first collision, starting to first collision, and first collision to second collision, that is going to be one time period. Okay. Now the cycle is getting repeated. Now what they asked is, they are asking you to find the average velocity of the Planck over a long time. So whenever there is a repetitive motion happening, instead of doing it for a long time, you can do it for one cycle, infinite number of cycles, n cycles you have. Instead of n cycles, you do it for one cycle because things will get repeated there. So now let us calculate the velocity. What I will do is I will take upward as positive j cap. Then in that case, you see displacement here. First displacement up to delta t1 is Vp into delta t1 j cap because it was going upwards. The subsequently Planck is going to go down. Particle goes up and comes down, forget about it. Planck we are talking about now. Vp into delta t2 downward. And whole divided by displacement divided by time interval, delta t1 plus delta t2 is going to be average velocity. Now we have calculated delta t1, this is the delta t1, this is delta t2. You are going to substitute them there and you will get minus Vp square by u into j cap. So this is the answer that we have. It's a very nice simple question. 2-3 simple ideas are added here, that's all. This kind of questions a student should be really good at. When will they be good at? When they have a proper understanding, proper command over simple ideas like this. So I hope you enjoyed it, you understood it, you revised certain important small concepts here. With that I will conclude here. Thank you very much for your time. Until next time, goodbye.